Alright class, so your homework is to do all of this. I will do some help with these. I'm not necessarily going to always write the answers, but I will provide some assistance on how you would solve them, and you can check your answers. Alright, so looking at the first one, what you want to do is figure out, we want to know what this f must be equal to so that it doesn't move, so that delta f is equal to 0. For delta f to be equal to 0, we'd have to have this f minus, let's call this tension 1 and tension 2 to be equal to 0. So, another way we can look at it is that if we move these over, the force must be equal to T1 plus T2. So now that we got that out of the way, this is our goal. So now we need to go about finding what T1 and T2 are. We can not just use that 700, as you guessed. It ain't that easy. Here's why. Remember, these get broken up into X and Y. So there's a Y for this T1, and there's an X for this T1. There's an X for this T2, and there's a Y for this T2. However, these things are equal to each other, so once you figure out one, you can find the other. And this is going to be some of that sine, cosine things. So since we know that this is 100 on this side, we know that this angle in here, even though it doesn't look like it, must be 80 degrees off the horizontal, and then this side must also be 80 degrees because we have 100 right here. So we have to do our sine and cosine. So remember, sine of theta is equal to the opposite over hypotenuse. Cosine of theta is equal to the adjacent over hypotenuse. Our hypotenuse in this case is 700. Our opposite of the angle is y. So y is our opposite over 700 is equal to sine 80. Cosine of 80, therefore, will be equal to x of 700. If you look at this, we don't care about the y. So you can do 700 times cosine 80 is equal to x, which is our T1 in the y direction, or the x direction, excuse me. And then when you solve this, it'll be 121.5 newtons. And then if we know this one is 121.5 newtons, the other one must also be 121.5 newtons. Therefore, F is equal to 121.5 plus 121.5, which gives us 243 newtons is your final answer. And then for the next one, it asks, how does the acceleration due to gravity on the Nerf guns compare? Hopefully you can think that for each case, so for case 1, it's A, B, C. For A, it's horizontally and will go down. For B, it'll go straight up and then straight down. For C, it'll go down really fast. But how does the acceleration due to the gravity? The acceleration due to gravity does not change. It is always 9.8. There is no change. So it'll affect your Nerf gun the same in each time. It'll just look different because you're starting from a different place. Hopefully this was helpful. Finish up this whole page and possibly more if you have time to make sure you're on track and ready for the final next week.